All right, y'all. We're gonna try something new. Forgive the sound of the car. It's loud, and the AC's on because it's incredibly hot. So here we go. Let's talk about the anatomy questions on your review sheet. Again, to reiterate, some of you seem to be very good auditory learners, so I'm going to offer you the answers in an audio format. All right, here we go. So the first question: how many phalanges are in the hand? On the video for the anatomy, I was wrong. There are 14 phalanges. There are 2 on the thumb, and then there are 3 on the remaining 4 digits. So 12 on those, 2 on the thumb, that's 14 phalanges. There are 27 total bones in the hand. That is including the 14 phalanges, the 8 carpal bones, and the 5 metacarpals. You add those up, there are 27. All right. The anatomic snuff box. So hopefully you've recognized that in lab. While we were talking, I pointed it out. There are 2 tendons when you extend the thumb that form like a little triangle. They used to snort like tobacco out of that, and that was the anatomic snuff box. What's interesting about that particular feature is that tenderness in that region is indicative or indicates a scaphoid fracture. There you go. The mnemonic for the carpal bones is, we've already talked about that, but make sure you understand how it's labeled. It's from the proximal row to the distal row, and it goes lateral to medial. So on the proximal row, lateral to medial, scaphoid, lunate, triquetrum, and pisiform. The distal row, again, lateral to medial, is trapezium, trapezoid, capitate, ama. All right? The next one is carpal tunnel syndrome. Carpal tunnel syndrome is where the carpal bones, there's a carpal canal in the carpal bone, where the median nerve and other things pass through. When that carpal canal begins to break down or to buckle, it compresses or puts pressure upon the median nerve, causing hand numbness or pain. And it's a nerve type of pain, just like a bulging disc would for the nerve roots that come through that region. Okay. Next, let's see. We're talking about the articulations of the structures from elbow to hand. This is like the humerus articulates the radius and ulna. So you have a humeral radial joint and a humeral ulnar joint. There's also a proximal radial ulnar joint that where the coronoid articulates with the radial head. Distally, there's a radial ulnar joint where the ulna and the radius articulate at the radial fossa there. And then you move on, and there's radiocarpal, there's an ulnar carpal. Then you have your you have your intercarpal joint, and then you have your carpal metacarpals. The most important carpal metacarpal is the one between the trapezium and the first metacarpal, because that is the only saddle joint in the body, and it's what really allows us to have our cool human thumbs, right? And then from there, you have your metacarpal phalangeal joints, and you know how to specify first through fifth. And then you have on the thumb side your interphalangeal joint, and on the following digit, or the remaining digit, you have a proximal, interphalangeal, and a distal interphalangeal joint. All right. Then we know the next one is the first carpal metacarpal joint. Then we know which processes go in the fossae on the distal humerus. Anteriorly, there is the coronoid fossa, which is kind of small, and posteriorly, we have a larger fossa for the olecranon. So when the arm is extended, fully extended and straight, the olecranal process is in its fossa, the olecranon fossa. When the arm is flexed or bent, the coronoid process is within the coronoid fossa. The bones of the hands on question 10 are labeled lateral to medial. That's how they are, 1 through 5, lateral to medial. The bones that make up the forearm are the radius and ulna, and when you pronate the hand, they cross over each other. All right, so that's a quick and dirty breakdown of the answers to the review sheet on anatomy. All right, we will move on into the positioning kind of projection question. Now, the letter E on that is talking about describing the anatomy that's included in each projection in terms of proximal and distal boundaries. So let me talk you through this from fingertips up. All right? Now, the fingertips, you're going to have the distal phalanx, or for the fingers, you're going to have the distal phalange to about an inch of the distal metacarpal head. That's for a digit. For the thumb, the first digit only, since you're centered at the metacarpal phalangeal joint, you will also include the entirety of the metacarpal, including the trapezium. Okay, so you'll have all of that there, typically on the thumb. For a hand, you will have distal phalanx all the way through and about an inch of the distal radius and ulna. For a wrist, you will center to the midcarpal region and include to just below the metacarpal head. Okay? On the forearm, you will be mid-forearm on your centering, and you will include both joints. And this is a rule for any of the long bones. When you image long bones, you have to include both joints on either side of the bone. So, for the forearm, you will include the wrist joint as well as the elbow joint. For the elbow, you will center to the mid-elbow joint, and you will include about 3 inches in either direction, distally and proximally. So those are the boundaries. The soft tissue, number 17, the soft tissue we include on the lateral elbow. We do that, discussed this in class, but we do that to make sure that we have the fat pads. Now, there are 3 fat pads, and you need to read about them in your text, but essentially they're close to the bone. But when there is an injury, a fracture of any kind in that region, there's a lot of fluid that accumulates, and it pushes the fat pads back. And so those are called elevated fat pads. So when those are present in a radiograph, then we are thinking that there is a fracture, okay? For a PA wrist, we flex the fingers to place the carpal bones closer to the IR, or to reduce the OID of the carpal bones. Any way of rephrasing that is appropriate. And then anterior and posterior displacement of fractures is best seen on lateral projection. So a lateral is going to demonstrate the anterior-posterior dislocation of a fracture. Number 20, open joint spaces on the hand on a radiograph are indicative of straight fingers, that the fingers are parallel to the IR. When that happens, your joint spaces are open. So whether the hand's flat on the PA or whether the fingers are completely straight on the oblique when they're elevated. That's what you want. And then as far as medial lateral or lateral medial projections go, on this particular section that we're studying, the majority of our laterals are lateral medial. What that means is the path of the beam moves from the lateral side of the body to the medial side of the body as far as anatomic position is concerned. Okay? So we only have 2 projections really that are medial laterals. So if you think of the second and third digits, when we perform the lateral of those, we do an extreme internal rotation of the hand and wrist in order to get them closer to the consent. So by doing that, we've now had the beam enter on the pinky side, which is the medial side of the body. That creates a medial lateral projection for those 2, okay? Now, I think that's about it. Again, make sure you're evaluating these things, these images, and you're looking at them. I'm going to do it like a brief talk through on some of the images, okay? And I know that we've discussed this, and some of you may or may not agree, but let's just talk about it. On a PA of the fingers, the thumb, or the hand, for all 3 of them, when we perform a PA projection and we're evaluating those, we look at the phalanges, or the phalanges. We look at those, and we look at the concavity. This is how we evaluate them. So when they're PA, there is equal concavity on both sides of the phalangeal body, right? Equal concavity and equal soft tissue. That means it's flat. When we do an oblique on either of these, hands or otherwise, let's talk about the fingers and the thumb. When we do an oblique on those, then we have greater concavity on the elevated side. When we roll externally, the palmar side is elevated, so we have greater concavity on that side than we do on the other. And then on the lateral, we basically have complete concavity on the anterior or the palmar surface and none posteriorly. Okay, that's the idea. On the hand, the PA, we have our equal concavity, plus we have limited superimposition with the metacarpals. And you're going to have to get that verbatim from your textbook. I don't have it in front of me. For the oblique, we have superimposition of the heads and bases of the metacarpals 2, or 3, 4, and 5. There's space between 2 and 3, and there's superimposition between 3, 4, and 5. Metacarpal head and bases on the oblique. On the lateral, the metacarpal should be fully superimposed. On the wrist, it's really just a matter of displaying the carpal bones. If they're there, we're good. Okay? Of note, on the wrist, on the PA oblique of the wrist, you visualize the scaphoid as well as the trapezium better on those, okay? So you should be able to tell me what bones those are if you see them. The lateral wrist really is just about superimposition of the radius and ulna. For the AP forearm, now we're talking the palms up, shoulders are the shoulder, everything's in the same plane. Proximally, we should visualize the radial head, the radial neck, and the radial tuberosity partially superimposed over the proximal ulna. Distally, there is some slight superimposition between the radius and ulna, but not as much. On the lateral, we should have the humeral epicondyles completely superimposed. We should have the radial tuberosity facing anteriorly, and the head of the radius should be slightly superimposed by the coronoid process, okay? So you should be able to, as I say these things, you should be able to visualize this image in your head. When you get to that point, this will be easy for you, okay? When we move into the elbow, the criteria is almost the same as the AP forearm, as well as the lateral forearm. So the AP, again, we have the superposition of the radial structures, the head, neck, and tuberosity over the proximal ulna. We have our epicondyles are going to be parallel to our facet, which means basically we're just a true AP. And then on our lateral elbow, we have superimposed epicondyles. We have a coronoid process that is superimposed over the radial head. We have a radial tuberosity that is projected anteriorly, and we have the olecranial process that is in profile posteriorly there. And finally, the last two, we have our obliques. Our external oblique or our lateral oblique will be what we're looking for. The main criteria is that the radial head, neck, and tuberosity are free of superimposition from the ulna as we rolled them out. And finally, for the internal or the medial oblique, we see the coronoid process in profile. So that'll be the last one. All right, guys, I hope this helps.